Hey guys, welcome to Coding in Flow. In this video we will learn how we can execute code on a separate thread in Android. This is one of the less interesting topics and there are a lot of convenience classes and external libraries that abstract that behavior for us, so we don't have to take care of it, but it's important to learn about these concepts nevertheless, so you should really not avoid it. Now as you might know, when we start an Android app we have one single thread by default, which is called the main thread. Another name for it is the UI thread, because it's responsible for managing and updating the user interface. Let's say for example we click a button. Then the button gets set into its pressed state, which changes its appearance like this. Then the onClick method is triggered, and then the button gets redrawn to its default state. All of this happens sequentially, one by one, but it happens so quickly that we don't notice any delay. Now the problem is, what if we click this button and then execute some long-running task before the button can be set back to its default state? Let's simulate this behavior. For this I have prepared the layout you just saw, and these two buttons here, start and stop. Call this start thread and stop thread methods, which right now are empty. So let's say in the start thread method we want to do some hairy operations. In this example we will just freeze the thread for 10 seconds. And we do this in a for loop. For int I equals 0. I is smaller than 10, we want to freeze it for 10 seconds. I++ to increase it with every iteration. And in here we call thread.sleep for 1 second each, or 1000 milliseconds. Now this could throw an exception, so we have to click on the slide bulb here and click on the round with try catch, and then we get rid of this warning. This way we can simulate heavy operations by just letting this thread freeze for 10 seconds. And also in each round let's show a log message so we see that it's actually running. For this I first create a tag with log t like this, which is a live template by the way. I press enter and it automatically creates this tag with main activity as a string. Now in the first line of this for loop right here I write log t, which is another live template, enter, and it created this log message which has the method name in the string here. Outside of the string I write +i to see in which round we are currently. So let's run it. So here's our app and here's loghead, and when I click this button it stays in the pressed state, our operation is running, and I can't change the switch here because the app is completely frozen. And now we get this thread example, which is the name of our app, isn't responding. And the same happens for any other long running operation on the main thread. So instead we have to put all this work into a background thread, which is not as hard as you might expect. There are two ways of starting a background thread, either by extending the thread class and overriding its run method, or by implementing the runnable interface and then passing this runnable object to a new thread. Thread and runnable are core Java classes, so they are not limited to Android. But there are some Android specific classes like handler and looper, which make running these threads and communication between different threads more convenient. And these classes on the other hand build the basis for higher abstraction classes like async task, handler thread, or thread pool executor. But don't get turned off by all these different names, we will take a look at the basics in this video. Okay, so as I said, there are two different ways to start a background thread, and we will start by extending the thread class. So I create an inner class, which I call example thread, extends thread. And in here we can override the run method, where we define our background work. So what do we want to do in the background? We want to do all of this what we previously did directly in start thread, which is this whole for loop. We cut it out, we delete the super part and paste it in. Now instead of hard coding our 10 seconds in here, we can also give this thread a constructor. For this we first create a variable in seconds, and then we create a constructor, example thread, where we pass in seconds as an argument. This dot seconds equals seconds. And now instead of 10, we pass seconds here. And now in our start thread button method here, we create an instance of our example thread. We call it thread equals new example thread, and we have to pass a number for the seconds, which is 10 in our example. And then we just call thread.start to execute it. So let's run it again. Now when I click this button, we still do our work, but this time our UI is still working. The other way of starting our background work is by implementing the runnable interface. So again we create an inner class. We call it example runnable. And this time we don't write extends, we write implements because it's an interface. Runnable. Now we get a warning because we have to override this run method. And here we want to do exactly the same. We want to execute this for loop. And the same as in our thread, we create a member variable for the seconds and a constructor. Like this. So now in our button method, instead of example thread, we create an example runnable equals new example runnable. Again we pass 10. But in order to execute this runnable on a separate thread, we still have to create a thread object. So write new thread, and here we pass our runnable as an argument, .start. Let's test it again. We click start, and it works as well. Actually, in both cases we execute a runnable because the thread class implements the runnable interface. This is why it has this run method as well. The runnable object basically just encapsulates the code that we want to have executed by a thread. Now even though the thread approach seems more straightforward and more logical, the preferred way is usually implementing the runnable interface and then starting it on a new thread. Because we don't actually want to change the behavior of the thread class, we just want to pass it some work to execute. Also this way we loosely couple the work that is to do with the choice of concurrency, because a runnable can still be executed on the main thread if we decide to do that later. Then we could just call runnable.run to execute it directly on the thread we are on at the moment, which is the UI thread in this example. However, both approaches work. Okay, and now let's say when we are at 5 seconds, we want to update something on the UI thread. Instead of adding another view, let's just create a variable for our button and change the text of this button. So I create a private button variable, which I call button start thread, and I assign it an onCreate button start thread equals find view by ID r.id dot, and I already gave it an idea button start thread semicolon. And now in our run method here of our runnable, when we are at 5 seconds, if I is equal to 5, then we want to change the text of the button. Button start thread, set text, I set this to 50%. Now let's run it again. Start, it starts counting, and at 5 seconds, our app crashes. Let's take a look at the logcat error message. We have a called from wrong thread exception, which says only the original thread that created the view hierarchy can touch its views. And this pretty much already explains what is wrong. Since these UI widgets are not thread safe, we can't access them from another thread than the UI thread. This is why we get this crash. And the same is the case for any other view, like text views or image views. We can only access them from the UI thread. So let's go back into our code. To execute this setText method on the UI thread, we need a so-called handler. So let's go all the way to the top of our main activity and create a handler variable here. Private handler. This one with the Android OS package name. We call it main handler equals new handler. This is not a core Java class, this is an Android class, which makes it more convenient to pass work to be done between different threads. Now by default, a thread starts, executes some work, and then it finishes. Now let's think about what would happen if this would be the case for our main thread. We would start our app, it would show the first screen, and then it would finish. So our program would be over basically. This would not work, so instead the thread has a so-called message queue and a looper which loops through this message queue and keeps the thread alive this way. This message queue contains packages of work to be done. So everything we do, like changing a switch or clicking a button, gets put into this message queue and then executed sequentially. The looper loops through this message queue, and this way the thread is kept alive and doesn't just finish when its work is done. And one responsibility of this handler class is getting work into this message queue. And by default, it's associated with the thread where we instantiate it. So when we write new handler here at the beginning of our main activity, this gets executed on the main thread. So this handler will only work with the message queue of the main thread, which means that we can use it to get our work to the main thread. We could also create a message queue and a looper for the thread we created. This way we could keep it alive and feed it with more work. but we only want to execute this once, so we don't need a message queue here. Now I know that this all can be a bit confusing, and I will put a link to a very good video into the description box below by the Android developer team where they explain this in more detail and with some nice images, so make sure to watch this video as well. But the point in our example is that we can use this handler, which we created on the main thread, main handler, to get work from our background thread here into the UI thread by calling .post, and here we have to pass a runnable as well, which we create with new runnable. So if you remember, a runnable itself doesn't start a new thread. Instead, it's basically just a package of work to be done. We close it down here with a semicolon, and then in here we write button start.setText and set it to the same text as before. Now this will work because the handler posts it to the UI thread. So let's test it again. We click start, and at 5 we should see our new button text. And this works. Perfect. Now instead of creating this handler on the UI thread, we can also create it here and just pass the looper of the UI thread. This is why I call this main handler to see the difference. So we can write handler, we call it thread handler, equals, then again we write new handler, and then if we don't pass anything here like this and try to use this handler to post this runnable, this won't work. Let's test it. Start. And we get a crash. Can't create handler inside a thread that has not called looper.prepare. Because a handler needs a looper and a message queue to work with, to feed it with packages of work. We didn't create such a looper and message queue in our background thread. But the handler we created here is tied to this background thread. Instead, we want to associate this handler with the main thread. And we can simply do this by passing the UI looper to the constructor. And we can get it with looper.getMainLooper. And now this handler will be associated with the looper of the UI thread. So let's run it again. Now it should not crash. Start. And at 5 our button should change again. And this works. But of course there is a more convenient way to do this, so you don't have to create this handler explicitly. For this I'm gonna put a comment around this. Like this. And instead we can take our button variable and call .post on here directly and pass a new runnable. And we use this post method the same as we used our handler post method, because internally it does the same. It's just a convenience method of the view class, and our button is a view. A text view or an image view is also a view, so we can call post on them as well. And there is a third way, comment around this as well. We can also just call run on UI thread, where we pass a runnable as well. Run on UI thread is an activity method. This is where we can call it directly here without any variable before it. And in here we can do the same. These approaches work as well, and I leave them as comments in here so you can take a look at the code in the description box. But as you can see, all this updating and running the background thread can be a bit confusing, especially when our app grows. And to make this more convenient, there are classes in place that make it easier, like the async task, which abstracts this functionality. And I already have a video on async task, which you can find when you click on the little eye in the top right corner of this video, so make sure to watch this as well. Now instead of creating a separate class which implements runnable, we can also use anonymous inner classes, which require a bit less code. So now I'm gonna put a comment around this part in our start thread button method. And instead we can just write new thread, pass a new runnable, define our work in here, just gonna write work, and down here where this red line is, we write .start to start a thread. And if you want to stop a thread before it's finished, you can do this with a boolean variable. So we would write private. Now I'm gonna write volatile, which is a Java keyword. This basically makes sure that all our threads always access the most up-to-date version of this variable and not the cached version. Boolean, we call it stop thread, and initially it's set to false. Now we don't have to set this to false explicitly because this is the default value, but I just do it for clearness. And then in our for loop, we can check for this variable. So we write if stop thread is true, then we want to call return to leave this run method. which will stop this thread because its work is done. So let's go into our button methods once again. We want to execute our runnable thread and not the anonymous one, so I'm going to put a comment around this. And in stop thread, we simply want to set this boolean flag to true. Stop thread equals true, which also means that we start our thread, we have to set it to false. And now let's run it again. Start, it's running. Let's see if it still updates our button properly. It does. Stop, and it stops. Can start it again. It starts, stop. Nice. Okay, so I hope this video helped you a bit. Don't worry if you're confused, this is totally normal because it's a complicated topic. Just watch it again a couple times and make sure to watch the video in the description box as well, which explains thread, message queue and looper in more detail. And don't forget to subscribe to the channel for more Android tutorials. Take care.